Some organisms, some organisms live in very hot or very acidic environments. Would their enzymes function in a person's cell? Why or why not? Why or why not? So when answering this question, we have to think critically. And as we think, what will first of all happen if an enzyme is moved from one environment to another? So if it has been living in hot and very acidic environment, then if you move it to a person's cells where the pH is about neutral, it's about 7, which is neutral, then we expect it not to function well. And the reason will be that the structure will be affected. And if the structure is affected, then directly even the enzyme will not be able to carry out its function. So the answer here is their enzymes may not function in a person's cell. The enzymes may not function in a person's cell. The enzyme may not function in a person's cell because the conditions have changed. Because the conditions will change. The condition we are looking at here, the pH will be different. So the conditions will change, and this, sorry, and this may affect the shape, may affect the structure of these enzymes. If their structure is altered, then it will not be able to carry out its function. So the enzyme will not be able to carry out its function because, sorry, function because the active site will not fit the substrates. So because the active site will not fit the substrate, then this enzyme will not carry out the function. Many enzymes in humans work best at nearly neutral pH. Many enzymes in humans work best at nearly neutral pH that is maintained within cells. That is maintained within cells of human body. So it's very clear here that enzyme action goes with shape. If the shape is altered due to factors like increase in temperature, the pH, or even other inhibitors, or inhibitors. So inhibitors, unlike the change in pH and temperature the which alter the shape, the inhibitors work in a different way in that they will block they will block or compete for the active site. Of enzymes, therefore rendering the enzymes less active or making the enzymes not to be able to carry out their function as they are supposed to. Number 4, predict. Suppose that the amino acids that make up an enzyme's active site are changed. Suppose that the amino acids that make up an enzyme's active sites are changed. How might this change affect the enzyme? So here, just like in the previous question, we will be talking about how enzymes are affected. So if the amino acids if the amino acids that make up if the amino acids that make up an enzyme's active site an enzyme's active site are changed, this will change the structure of the enzyme. This changes the structure of the enzyme This changes the structure of the enzyme and make it not to function. So if it's not functioning, then it will not carry out its activity because different amino acids have different shapes. Because different amino acids will have different shapes. Structures. So the change in structure directly will affect the performance of the enzyme. The change in structure will directly affect the enzyme. So we will stop there, or we still have one more question. That is question number 5. But we will stop here because sorry, here you have the question number 5. Organisms need to maintain homeostasis or stable internal condition. Why is homeostasis important for the function of enzymes? Why is homeostasis important for the function of enzymes? So the answer would be something like homeostasis or stable internal conditions is important. I mean stable. Stable internal conditions is important. Is important because enzymes depend on its structure to function. To function properly. So if the structure is altered, then it will not be able to function properly. So conditions must be maintained, must be maintained at a constant condition in order for enzymes to function best. So it is very important to maintain homeostasis because any change in pH or temperature can affect the shape and the function or the activity of an enzyme. Can affect the shape and activity of an enzyme. So enzymes work best in small temperature ranges, for example. They work best in small temperature ranges. An increase in temperature will directly affect the functioning of an enzyme.